There we are.
Really? On my beef.
You know, my cousin got a kidney transplant from his mom
Really?
when he was like 6 or 7. It was one was failing, so his mom smashed it. She was adult, so she donated hers to him.
Are they okay?
She's fine. They're both just have to be on medication for the rest of their lives. Like they each take like a big thing of meds. But other than that, he's been healthy so far. And yeah, they haven't had any complications.
Yeah, I wouldn't want to give my kidney, but yeah, the only one is my child or something. Is the same thing. I don't know if I'd give it to anybody else.
He was so young when it happened, and it was for sure failing.
Right.
One was about to go down, and and he was so young, so like you need another one. So right now he still needs to develop. So they matched them, and she was like, "Well, I'm already a person, and I can survive with one."
Right.
With assistance, but here, like, and yeah, and he's 19 now.
That's
20,
cool.
and they're both like,
The wells are the little.
That's scary.
so I'm really excited to learn
The
about
little.
Well, we're going to learn a lot about. So let's everybody. This is baby kidney, but it's going to give you a taste of what the kidney does, and we're going to start. This is going to be my nephron here. You're going to be drawing nephrons so you can actually know it. And again, what we're going to concentrate on, you can kind of see it here, are going to be sort of the first basic couple processes. Okay? So the couple slides again are just introducing us to the fun of the kidney. Now, usually on this first section, we sort of list what are some overall functions of the system. Well, the kidney's got 2 slides. That's how much it does. And that's just we're gonna the details of this, the devil in the details, really will start coming out in the next chapter as we go. But let's just step back and see the forest before we start looking at it. So, along with the cardiovascular system, which we all know and love, obviously the kidney is going to basically help control volume and blood pressure as well. Blood pressure is high, it's going to get rid of more water and salt. Blood pressure low, it's going to conserve, right now we use that word, but salt and water. That makes sense, and we'll show you how. Okay, osmolarity again means salt concentration. We remember that we want the osmolarity of the blood and everything to be isotonic with the cells. But we're varying how much salt's in our body and all that, so it's going to control the osmolarity. If we start putting too much salt in our blood, we are going to excrete that salt. If we don't have enough, it's going to help conserve that salt. So it's not just controlling water volume, it's controlling overall salt concentration. Okay. Not only that, every ion we've talked about in this class that has critical function, sodium, potassium, calcium, chloride, phosphate, hydrogen ions. Remember, we need them at particular concentrations. The kidney microtunes all of those ions. So it's not just doing overall salt concentration. It's going to have segments which will control exactly sodium levels, potassium levels, calcium levels, hydrogen levels. What do hydrogen levels mean to us?
pH.
And so this, again, by next time we do this, we're going to see what using our friend, which is not up there anymore, this, California is our carbonic anhydrase. Using that same equation we just showed, we're going to show the kidney cells have that in their cells, and they're going to control our acid base. If we become too acidic, we are going to pee out the acid. Okay, basically, to say it, crudely. I shouldn't say it that way. We're going to excrete excess hydrogen. If we don't have enough hydrogen as it's going through, it's going to reabsorb that hydrogen back in our blood. So back in the beginning, when we were doing this fun thing for metabolic and respiratory acidosis, alkalosis, we said for the respiratory, kidney responds. Well, we're going to find out how the kidney responds in the next couple weeks. We made it, okay? I dream of these weeks, okay? At the beginning of the semester, I'm like, okay, yeah, we got to do that. I'm dreaming when we get to this point. And if you can hang in there, okay, just try to stay up with me the next couple of weeks, you're going to just be amazed. You're never going to pee the same again, okay? I promise. Oh, yeah, it does filter blood and eliminate waste. Yeah, we kind of knew that, right? But to be an overachiever, why don't we produce hormones too, like endocrine glands? Sure. And so it produces two of them. EPO, that's erythropoietin, EPO. Okay, for some reason people didn't remember that one, but next time I'll have to just put Lance up there with a big EPO or something like that. That stimulates red blood cell production. So we said that before. Renin is going to be something important in chapter 20. It's going to be important for controlling sodium, okay? For how much sodium stays in or goes out the body. If we want sodium to stay in, we're going to have renin. If sodium stays in our body, what else is happening? Who follows sodium? Water. Okay? Wherever we're moving salt, we're moving water. If our blood pressure is low, we're going to make sure that we keep sodium in the body, water will follow. Okay? So again, we're going to play, it's all about osmolarity, and that's why chapter 20 is called osmoregulation. But it's fun. Okay? Osmolarity is not bad, it's a good thing. Alright, that's kind of what it does. There's anatomy, there's the kidney. There it is again. So, the real idea will be coming up, we're going to be talking about the nephrons, the functional units. But when we start looking at some of these factoids, which we'll start seeing in the next few slides, a tremendous amount of blood, we're going to see how much filters through the kidneys a day. At any given time, under normal conditions, about a quarter of our cardiac output is going through the kidney. So the kidney is doing some major filtration and all that fine control. And so we need to look at the blood supply of the kidney and the nephrons as we're going to go. One more sort of anatomy picture. Yeah, we're going to concentrate on these, the nephrons. But overall, just to kind of get the orientation here, I do want you to sort of realize when you take a cross-section of the kidney, we have sort of this outer region of the kidney, cortex, and then the more inner region, the medulla. And that's going to be sort of important as we go through the next couple of weeks. Just sort of that orientation of the outside and inside. Cortex and medulla. Now, once all the stuff we're going to talk about, all this filtration process in these nephrons happen, what's going to end up urine is going to kind of drain to this renal pelvis and then the ureter, etc. So that's just basic anatomy of this. But we're really going to concentrate on these guys, the nephrons. That's the functional unit of the kidney, and there are 1 million of them per kidney. Okay, 1 million nephrons per kidney. And you can kind of look at this picture, and we're going to start naming parts of it. Most of them, we're going to start looking at this little loop here as we draw it. Most of them just have their whole process in the cortex when we look at this loop. Those are called cortical nephrons. But some of them, about 20%, have these loops that extend deep into the medulla. And these are called juxtamedullary ones. These guys, chapter 20, these guys are going to be important for being able to concentrate urine or making it dilute, okay, when we're talking about that. And we'll show you that. So we're going to talk about all nephron function, but when chapter 20, when we start talking about making very concentrated urine and how to control that, we're going to be talking about these guys with these long loops. But that's nephron. So what we're going to do in the next couple slides are the following. And I sort of have it up here. That just hard to sort of see it. Get bigger. I'm drawing the nephron. The parts of the nephron. Okay, and we'll see that as we go in a better picture here. And the first thing we want to talk about is the blood supply to each nephron. Okay, to the kidney. Now, overall, because a lot of blood's going through there, we're going to have blood enter the kidney through the renal artery. But what we care about now is what is the blood supply to each nephron. Okay, so we get in the kidney, and what we're going to find out, and we'll see in this other picture too, we have blood entering each nephron through something called the afferent arteriole. Okay, that's coming in to the area right here. Okay, that's the afferent. And then what we're going to have then is covering the bottom here. The actual place where we're going to do the filtration is a specialized capillary bed called the glomerulus. So we're talking blood supply right now. We haven't named all these parts of the nephron. We're saying, okay, blood's going into the whole kidney by the renal artery, but now we're branching out to these 1 million nephrons. And for each nephron, we're going to have blood entering through this afferent arteriole. It's going to have this capillary bed, which will do the filtration in a minute, called glomerulus. Now, not everything is going to make it in. And so usually, gotta go back to this picture. Usually after you go through a capillary bed, you're to a vein, but we're not doing gas exchange. So we actually go to what's called, I'll put an arrow here, the efferent arterioles. Actually, I'll tell you why it looks like that in a minute. I actually want to use this figure right now. I'll show you why it's so complicated in a minute. But this is a better picture showing it, so let me just use this great picture. So we're talking blood supply right now. Blood supply is going in the afferent. We're going to talk about filtration here, and we have this idea that the glomerulus or the capillary bed, what doesn't make it in goes out the efferent, and then comes the last sort of element we want to talk about blood supply called peritubular capillaries. And so the peritubular capillaries are running along the parts of the nephron, because what we're going to see, this slide is going to help show us, that once we get something in, we're going to do a lot of interaction with the blood again. We're going to be reabsorbing some things back into the blood, that's what R will be, and we're going to basically get other things from the blood into the nephron, and that's going to be called secretion. So we need these capillaries working all the way around the nephron. So, blood supply. We have blood, and this is for each million nephrons, right? We have blood that's going to reach this thing by an afferent arteriole. It's going to go through a capillary bed called the glomerulus, in which we'll talk about how we're going to filter things into the kidney then, in the nephron. What doesn't make it in is continuing along the efferent arteriole. And then we have these peritubular capillaries, which we're going to do a lot of exchange over the next couple of weeks. Okay, so they extend all the way around each segment of the nephron. Okay, that's the blood supply. Right now we're introducing this. And again, some people may have had some of this in anatomy, but if you haven't, it's not a big deal. We're just kind of getting the overall sort of structure of everything. Any questions about that? Just the names of the blood supply, or kind of see the flow here. Okay, I have my diagram here, but you can look at this one. It's better than the other pictures for various reasons. We're basically going to just make sure we know sort of this idea of these the tubular parts of the nephron. And so, again, I have words on the handout, so I can really just point to this. The very first segment of the nephron, in which the filtrate basically comes in, is called Bowman's capsule. So a little anatomy here, but we need to do the function of all these. Then it's going to reach the first kind of segment here, it's proximal, so it's proximal tubule. And today we are going to definitely talk about, this chapter talks about what happens here for sure. So proximal tubule. And then we've got a loop. And we call this the loop of Henle. But if you look at this, okay, we're going down and we're going up. Even by the cartoon, does this look exactly like this? Does it?
No.
No. We're going to see functionally what happens in the descending part will be different than the ascending part, at least in chapter 20 will. Every segment here is going to do something different. Every segment's going to do something different. So right now we're just sort of making sure we can name the segments, and then we'll talk about it. So we have Bowman's capsule, we have proximal tubule, we have the loop of Henle with this look, the descending and ascending looking different. Then we have the distal tubule, okay, proximal, distal, and then finally what we're calling the collecting duct, and that will end up being urine. So what comes in, we're going to do a lot of stuff before it actually becomes urine. A lot of stuff. That's how those first two slides we talked about, it's controlling this, controlling this, controlling this. This is going to be the beauty of how each segment is doing something different to do those first two slides. Okay, control every ion, control salt balance, control water balance, etc. It's going to be the magic of what happens here. But right now it's just getting oriented. So we've got the blood supply, and we have sort of at least the names of showing you tubular elements. Again, you should draw these out, and basically as we go through it, you're going to end up practicing what happens in each segment. Let's go back a second. Again, again, I have all, this is a different picture of it. I said all this. Again, it's in the notes. Again, the different components. Descending, ascending, that's a loop of Henle. And you can see in real life, too, they're convoluted. So that's the way they look. But there's proximal and distal. What's the advantage of having it, instead of a straight line, having this convolution? Surface area. We want a lot of exchange between this and the blood, and so that increases surface area. So that's old news for us, but that's a major function structure. Okay, so we're actually to the slide, because we'll see why that looks like that in a minute. So this is sort of, again, beautiful slide, these couple, because look how simple this is. And we want to make it simple before we make it complicated. Okay, we've got to know the framework here. And really, if you look at what happens in the kidney, the nephrons, there's these 4 processes. And you have to, especially these, make sure you get the terminology down. So filtration, which we talk about in this chapter, and we'll talk in a minute, is basically what gets in from the glomerulus. And we're going to talk about that next. Sort of what actually gets in and what doesn't. That's called filtration. But as I said, what starts here isn't necessarily what gets excreted. We're going to do a lot of modification. And whenever we're taking what got in and putting it back into our body, putting it back into the blood, we call that reabsorption. Remember, we called lumen sort of this, the inside of hollow things like the GI tract, or now we're talking about the kidney. This is all the lumen of it. So when we're going from the lumen back to the blood, reabsorption. If we're taking something else from the blood that we didn't get in this way and putting it in, that's called secretion. Blood now entering the lumen, okay, of the nephron. Finally, excretion is what makes it out. Okay, those are the 4 main processes here that we're going to talk about. Okay, in this chapter, we're going to talk about filtration, and we're going to talk about reabsorption here. Then next time, we'll start getting complicated. It'll get more complicated. And another, again, all those words are up there. Another simple picture, even simpler than that one, which is nice, is this one. That basically, that if you look at some of the overall process here, if we want to see sort of how much, how the kidney is functioning, etc., it's going to be this. It's, if we're looking for a given substance, we're looking at how much is in the urine, it's going to be how much got in minus how much was reabsorbed plus any additional that got secreted. That's going to actually be what gets excreted. So it's kind of a simple formula here. And in real life, it gets real complicated. You actually use this. You take blood samples, you take urine samples, and you can start determining a lot about how the kidney is working, or maybe something else going on in the body. Urine samples tell you is the kidney working, but also says what's it's a reflective of what's in the blood as well. So it could be indicating diabetes, as we'll show, or any other metabolic diseases too, because what gets out there could be different. So measuring blood samples and urine samples are very important. It's kind of a simple formula. But the 4 processes. Does everyone sort of get the 4 processes, on this slide? Filtration, which we're going to talk about next, is going to be sort of what gets in. But reabsorption, we're going to keep using that. We reabsorb most things. It's going to be what gets back. Secretion gets in.
What are some examples? Weren't there like ions and things that it's reabsorbing?
Yeah, exactly. I mean, actually, we're going to see it's going to reabsorb a lot of stuff that gets in right away. Really, all those ions and a lot of other things as well. So the first thing we're going to talk about, that will have at least this period here, and then we'll take a break and see who leads, who goes. The first part is filtration. Let's talk about how that works. And basically what it is going to be size and charge. Let me kind of make this simpler here. Just to have this idea of filtration. I just do my other chart. So if you look at the structure of sort of this idea, this is the glomerulus, so this is the blood, and here is the lumen of Bowman's capsule. Okay, so that's the epithelial lining of that. You basically see that both of these cell layers have basically in between the cells wide open. Okay, so basically pores. And so this was, we called this in the last unit, fenestrated capillaries, right, when you have large pores for a lot of movement. So that's what the glomerulus has. They've got these large pores, but when you look here at Bowman's capsule as well, so the entrance to the nephron, they also have it. So large things can't pass through. Small things can. It's not selective for particular ions or substances. It's size. Small things pass through, big things don't. What are big things in the blood? Cells. Remember, the blood consists of cells and the plasma, everything dissolved in it. Cells are too big. Cells are not going to make it in. So that's what the size sort of is, size exclusion. There's three barriers. Two of them are size. If they're too big, they're not going to get in. That's going to keep cells out. Now, there's one in the middle. This extracellular matrix called the basolamina is basically, we can kind of put it, is negatively charged. It's got all these proteins and sugars that are negatively charged. So it's like a big negative sort of barrier here. Now, most proteins are negatively charged. So when proteins see negative, what happens with negative? Repels. So basically, cells and proteins don't make it in. Most everything else that's in the blood is going to make it in. So, does water make it in? How about ions like sodium, chloride, etc.? Sure. How about waste products like urea that we're trying to get rid of?
Yes.
Sure, that will make it in. How about glucose?
No.
Yes. Oh, I know, I tricked you, I'm sorry. So, glucose, small, it's going to make it in. Just because it makes it in, does that mean it's going to be excreted? What are we going to do to it?
Store it in the
Reabsorb. The key word is reabsorb. We're going to reabsorb all of it. It's going to be right away, by the way. So, but it freely comes in. How about amino acids? Things that make up proteins that we need. Do they make it in? Yes. What are we going to do to it? Reabsorb it. So all of these substances make it in because really all we're doing here at this point is keeping cells and proteins out. We're not selective here. We're gonna do a lot of manipulation before we end up going to the toilet. Okay? But right now, everything gets in except cells and proteins.
Are hormones too big to get in?
Yes. Well, because most of the hormones really won't make it in because they're either proteins, okay, like insulin and glycogen, or else they're big fat type ones like steroids, and they won't make it in as well. So they're not going to make it in, when it comes down to it. But they're sort of these classes.
What about like pregnant women? I heard that in their urine, like I guess that's how you can detect it, like through a hormone that's released.
Yeah, I mean.
That's unexpected.
No, I mean I don't know. I have to go through every hormone and see like which one is that. That's gonadotropin releasing. I don't know. I've got to look more at that. I'm not sure of every hormone that gets in. But these substances definitely get in. Salts get in, glucose gets in, amino acids gets in, and urea gets in. Okay? We just keep cells and proteins out.
Plasma goes into.
Well, that plasma is water with those dissolved substances, right? This is just another picture. And then we'll just some pictures to kind of see an orientation. We're going to talk about this after break. But what you can really see, again, is that afferent arterioles are bringing it in. Here's the glomerulus, in which we're going to filter to Bowman's capsule. And you can see what doesn't make it in goes through the efferent. Sort of a nice little picture. You can look at some of these just to visualize versus something like that. Just the structure of it. And that's sort of the real structure, so that's sort of cool to see. Okay, we'll do this, and then we'll see who's going to stay, who's going to go. Let's look at this for a second. This in the next couple of slides. This is kind of an overview that we're going to see as we go. That really will show you a couple things. We're examining how much fluid, and then we'll look at the salt concentration, which is really going to be chapter 20. But we look at the fluid going through all of our kidneys at any given place. And you're going to have an amazing number. I might have mentioned this before. So we're looking now, let's just look at the fluid. Okay, like how much water. And if you look at, again, here's the structure of it. If you look at how much water is entering Bowman's capsule, your 2 million nephrons a day, it's 180 liters a day. Is that a misprint? No. 180. 180 liters a day of your blood is being filtered, and it's going to reach basically this first segment. if you look at the next slide, just to show it, that without looking at the top part, we'll talk about it, your plasma is only 3 liters. That means 60 times a day, your entire blood supply is being filtered under normal conditions through your kidney. Okay, those are those amazing factoids that, I wake up in the middle of the night and like, really? Because that's a lot of fluid. Okay, just like if you only have 3 liters and you come up with a number like 180 liters a day, there's no way you would think that's true. That's just way too much. But this is the idea. You don't want to think of your kidneys doing all those functions we said in the first couple of slides, like, okay, at 9 o'clock it's going to do that, right? It's constantly doing this, 60 times a day. We're micro-tuning everything that we're going to be talking about. So it's quite a bit, okay? I think that's quite a bit. So that's 180 liters a day. If you look about at the end of the proximal tubule, which is here, and how much is passed through there a day, it's 54 liters. So if 180 liters make it here, but only 54 liters make it here, what happens? Reabsorption. We're going to reabsorb most of the water right away. The words, which I'll even leave now before we kind of finish that part, that we're going to do within a half hour or so for people saying is the proximal tubule, bulk reabsorption. If you do leave, look over the notes and see what questions you have. Basically, almost everything that we put in, including most of the water, will be sucked back in and reabsorbed right away in the proximal tubule. We put it in, we put it back. And you can see that with the water. If you look at the end of the loop of Henle, here's the loop of Henle, 18 liters. So what happened to water here? More reabsorption. Okay? And then, again, if you get to the end, only 1.5 liters. So 180 liters come in, only 1.5 liters on average go out. So basically, 99% of what goes in gets reabsorbed. Okay? That's sort of a factoid. So overall, we're putting it in, but we're putting most of it back. But we're going to micro-tune that 1.5 liters as we need it. Okay? Now, the other thing, then we'll be done with this, what we're going to end for now, because that's sort of class period, is this will be Chapter 20, but I just want to show you the preview of why Chapter 20, why you're probably going to want to read this over this week anyway, is look at the osmolarity. Now, the osmolarity of blood is about 300. Okay, that was isotonic, 290, 300. When it enters, when we filter it in, it's still 300. Even after this bulk reabsorption we're going to describe in a few minutes, it's still 300. Now, it's going to be more complicated than that, but at the end of the loop of Henle, it's 100. Now remember, numbers like this, osmolarity means salt concentration. So we have 300 here, 100 here. What must we have done to that salt? What's the key word? Reabsorb. We're going to reabsorb salt here. Okay? Now, at the top of here, they don't put it, it's 50. So the idea will be, and we'll see this will be the magic in Chapter 20, that no matter what the condition in your body, after we go through this complicated process, that the osmolarity at the top of the collecting duct, that's this last segment, is 50. Okay? Pretty dilute. Remember, 50 is a very dilute type of urine. Now, at the end of the day, or whenever you're going to the bathroom, okay, at the end of the day, even though urine's starting out the top of the collecting tube at a very dilute 50, your urine coming out can be anywhere between 50 and 1,200 milliosmol. Okay? And that doesn't just mean 50 or 1,200, it means 50, 55. So all concentrations in between are going to go, they all start at 50. By the time you reach the end, depending on what you need, okay, you either have very dilute or very, very concentrated urine. All that's happening here in the collecting duct. The collecting duct doesn't just collect. Okay, how does it do this, you ask? Magic. Chapter 20. Okay? Chapter 20. Chapter 19, for people that are leaving now, you want to go home and look at your notes. We're just going to talk about 2 things. That's all this chapter talks about. We're going to talk about control of filtration and this bulk reabsorption. That's it. We stop here with 19. Okay? 20 is where we get to do all of this. So what we're going to do for the people today, we're going to do those two things. What controls filtration, and then this bulk reabsorption. If you leave, review those slides or review the handouts, or if you read the book, review that part of it, see what questions you have. Remember, even if you leave, you can't do it now. I'm there at 4. I was there at 4. Nobody showed up except one person to say hi. Okay, I'm coming early. I'm flying from San Marcos. I'm going through traffic. Okay, dodging BMWs and trucks. Okay, to get here. I'm there if to do that. So I'm there at 4. I'm going to be 4 to 10 a week from now as well. And so, but I am going to start on chapter 20 pretty quickly, and so you want to try to catch up. I'll do some 19 review, but if you come in like not doing anything between now and then and you leave now and you haven't even done 19, you're going to be in a big hole. I mean, it's a hole that's going to get bigger because chapter 20 is a major thing, okay?
You're starting 20 today?
No, next time. But we're going to do 19. Okay, the rest of 19. We've done half of it. We're going to do the second half, and then I'm also that might take 45 minutes, from that, for that. And then I'm still going to be here for people that want to stay longer and go back over everything I just did. Okay, lecture 2. I actually had a student a couple semesters ago who was, actually this guy was in the military. He took anatomy, physio, and micro at the same time. He wasn't working, okay, but he did take all that. But he was like this totally intense, dedicated guy. He was a really nice guy. But he literally, like every lab, like say I'm there at 10 o'clock, he'd be there, like I leave at 8:30 for people, and he's like, okay, lecture 2. And we basically went over everything that we did in lecture, but now instead of having, up in front of all these people, it's in front of 2 or 3 people. All that's available for you. You have paid for that, okay? So just say goodbye to your family. Okay, this is the time you at least have the opportunity to do that. Okay, see Lynn, but again, I'm going to be here 4 to 10, 4 to midnight. I don't really care, okay? So I'm here for you guys if you need it. Okay, but now I'm going to take a few minutes because I want people that are going to go. At 7 o'clock or so, we'll continue this chapter. If you are leaving, if you haven't done so already, pick up your lab test. Okay.